it's my pleasure to kick off this fantastic conference already in its 7th year, and now in Europe, one of our home nations of Airbus. I would like to thank the organizers, first of all, for allowing me the opportunity to share with you how we want to bring aerospace into the quantum area and why now. I really love this picture because it captures a lot what we do. Most probably you know us for our civil products. Here you see the A350, the bigger one, and the smaller one, the A320. We have built more than 14,000, and each 2.5 seconds, somewhere around the world, one of these take off. But we also build military aircraft. Here you see the example of the A400M, military transport aircraft. And on top of the picture, you see helicopters we are building. What you cannot see in the image is our space segment. We are Europe's largest spacecraft manufacturer, and we help to deliver the benefit of space down on Earth each and every day. I don't know if you're aware, but space is essential for the daily running of our societies and for the safety of our nations. Space is essential for connectivity, for climate monitoring, or for security. And it's also the epitome of humanity's desire to explore and learn. And what we learn in space serves us often as well in unexpected ways on Earth. The solutions we build in Airbus today and for tomorrow is really an integral part what drives our company, my colleagues, on this critical path to our future. Let me phrase it maybe in my own words. I believe the future of aerospace is sustainable, is even more safe physically and digitally, and is even more connected, thinking about people, goods, and data. Now, the collective challenge ahead of us is clear. What is also clear is that there is no silver bullet. As engineers, we are set out to develop various technology bricks to enable our future, consisting of existing technologies, but also leveraging new emerging technologies we see out there. One of these most promising emerging technologies we at Airbus, we see at a fast track to maturity, is quantum technologies. We are convinced quantum technology will be one of the next game changers for aerospace, and therefore we are already very active in this field, really as an early adapter. We are pushing to understand and to explore what quantum technologies have to offer in their distinctive fields. We see clear use cases in all of the pillars, in quantum computing, quantum communication, but also in quantum sensing, and I would like to tell you now why. Well, engineers used to say that an aeroplane is 10,000 mechanical parts flying in close formation. Today, aerospace is much more than just the sum of its mechanical parts. Aerospace has shifted from a nuts and bolt business into one of the data richest and data-dependent industries in the world. On average, an aeroplane carries about up to 10,000 sensors, which are collecting a vast majority of data points, up to 400,000 parameters. They are compounded, they are analyzed. And the value of this information is significant. Just think about to use the data for predictive maintenance. We will benefit from quantum computing as it enables us for significant time and cost savings in complex problem solving compared to traditional computation methods. Quantum computers will be able to solve complex calculations in a matter of weeks, where classical solutions would sweat for millions of years in theory. And as already mentioned before, we see it as well as a clear opportunity to lower overall the energy consumption in comparison to classical solutions. The key to controlling big data complexity is the increasing of computing power. Today, we are packing more and more transistors onto computer chips. But these advantages really come to its physical limits, struggling to meet the demand of an increasingly complex world, which is even more increasingly complex challenges, which are rapidly extending beyond today's technologies. Quantum computers will allow us to tackle more complex topics. Just think about optimization, such as we see for flight path optimization, which implies, of course, a more efficient operation. Or, for example, the enhancement of simulation modeling capabilities, like, for example, for computational fluid dynamics, which will lead to a more efficient design. Or chemistry challenges, as for the design of a fuel cell for our new hydrogen-based zero-E aircraft concept. Now, with all the excitement about quantum computing, we should really advance with caution. I believe that quantum computers will not replace high-performance classical computing in the future. However, we are looking into hybrid solutions, really combining these classical solutions where needed with the power of quantum computers and its enhanced capabilities. I strongly believe that by applying the strengths of each of the technology, quantum computing will really enable high-value solutions in the future. Moving on, exploring how quantum technologies bring value to the aerospace industry, let's have a look to quantum communication. The progress in quantum computing, as we just discussed before, is a double-edged sword. Why? Because the risk to data security is real. And before going into more details about, how quantum can be the solution of its own problem, I want to explain to you more about why this is so important for our industry. Safety is the highest good in aviation. And therefore, it's in our DNA to deliver aircraft at the highest possible safety standard, without any compromise. This is what the more than 3 billion passengers per year, and I assume yourself included, you expect from us. We need to ensure secure communication between the ground and the platform, whether it's an aircraft, a helicopter, a satellite, a drone, it doesn't matter. We need to ensure the secure communication between the platforms and a secure connection in satellite communication networks. All data on an aircraft is, of course, encrypted. Today's cryptographic algorithms, such as commonplace encryption using the asymmetric keys, they will simply not be able to withstand attack of a quantum computer in future. But we need to keep the same level of security also in the future. Interestingly, here it's quantum itself that can provide the answer on the challenge. We really rely on quantum communication solutions. Airbus is very active in conducting, on the one hand, scientific research, but also developing solutions for secure communication infrastructure, targeting quantum key distribution and post-quantum cryptography. But also, if you're looking more into the future, we are working on quantum information networks. Secure communication has also been understood as a key contributor to Europe's push towards strategic autonomy. And therefore, the European Commission has launched in 2019 the European Quantum Communication Infrastructure Initiative, EuroQCI, in which Airbus is strongly committed and engaged both on terrestrial and space segment level. And here I can warmly recommend you to listening to the presentation of my colleague Jasper Krauser, our Airbus Quantum technology leader, at 11:10 in the communication track today. Another opportunity quantum technology is providing is completely new sensing capabilities. Quantum sensors are not only more sensitive as its classical counterparts, they also offer a much lower drift, which is extremely interesting for aerospace. Why? Just think about navigation sensors. We are investigating how quantum sensors could be used to further improve aircraft safety, providing accurate inertial navigation. We assume, or we expect, that with this quantum technology, it will allow us to provide navigation capabilities which are so accurate that we don't need to rely on global navigation satellite system in the future. Another super exciting development in Airbus is a novel quantum sensor for space, which will be a breakthrough in measurement of the Earth's gravity field. It's really a first of its kind. The quantum sensor is based on atom interferometry with an ultra-cloud cloud of atoms, which is already a challenging technology as such. But now we need to get it working in the extreme environment of space. So Airbus is working together with strong partners from academics and from the industry in Europe to get such a sensor ready for the orbit around 2030. You may ask yourself, what is the benefit? Well, I've already mentioned that with this technology, we are able to measure the Earth's gravity field in an unprecedented accuracy. So here we expect about 1 order of improved accuracy. So these data are essential for climate researchers. They need this accuracy level of data for improved or advanced climate modeling. I assume we all agree here that quantum is a game changer for society. And we in Airbus, we really believe we need to even further explore its potential for the aerospace industry in order to continue to be an early adapter. At Airbus, we are really privileged having the opportunity to work on such a technology which will offer opportunities for a safer, a connected, and more sustainable world. Our early stage venture capital company named Airbus Venture is also deeply involved in supporting new companies which are developing quantum solutions. My colleague Mathieu Coste will be part of a panel discussion tomorrow, so I can warmly recommend you to join the session at 11:20 in the computing track. Now I'm convinced that we can leverage the full potential of quantum technologies for aerospace only in an inclusive way. Airbus is strongly committed to work together with academics, industries, but also, of course, the governments. We can only harness the full potential of the technology if we develop these technologies together. Together with you here in the audience today, together with the overall aerospace ecosystem, and even beyond, across industries. So I'm looking forward meeting and discussing with you together with my team here later during the day or in the future. And if you want to be part of enabling aerospace future, just use the QR code and reach out to us and let us discuss when you would like to join us. Thank you.